Right, this recording is to help you with lesson 6.02, the law of cosines. Alright, we can solve triangles using the law of cosines also. So if you find out you don't have enough information to use the law of sines, you might be able to solve it using the law of cosines. Alright, one way we can use the law of cosines is if we're given all three sides. Okay. Another way is if you're given two sides and the angle not between them, or the angle between them. Basically, if you're given side AB and angle C. So that's another way we can use law of cosines. Notice that there are actually 6 different formulas for the law of cosines. Okay, you have the standard form and you have an alternate form. All right. So depending on the information given depends on what type of formula you should use. So here we're given all three sides. We're going to use the alternate form to try and solve for one of the angles first. So for this one, we're going to solve for angle C first. So cosine of C equals a squared plus b squared minus c squared all over 2ab. And notice there is a pattern here. It's always 2ab. So it's always the 2 on the bottom of the sides you're not looking for, or that angle that's not there. And then we're just going to plug in the information to solve. So here we actually get 81 plus 144 is 225. 225 minus 225 is 0. So to find the actual degree measure, remember we use cosine inverse of 0. And make sure you are in degree mode. That equals 90 degrees. Okay, you can use, once you know it's a right triangle, then you can set it up, ABC. So C is your 90 degrees. We'll just do AB here. This is 9, 12, 15. You can use your law of cosines again, or you can set up and do sine of A is 9 over 15. So cosine inverse, or sine inverse, sorry, of 0.6 gives me my 36.9 degrees. So you can do it that way, or like I said, you can do the law of cosines again to find another angle measure. And then once you have 2 angle measures, you just subtract from 180 to find that last one. So again, many different ways that we can actually solve this triangle, as long as we get 90, 36.9, and 53.1. Okay, the next one, we have a parallelogram. So you need to keep in your head that this is actually a parallelogram and there are properties that we need to know. So I'm going to look at this part of the triangle first, AB, and I'm going to find side length D. Now D is in fact the whole diagonal here. It says the lengths of the diagonals are given by C and D. So I have 2 sides and the angle in between, so I would have to use the law of cosines to find length D. So D squared equals your 2 sides squared added together, minus 2 times the 2 sides multiplied together times cosine of that included angle. Okay, now don't forget to find the length of D. You're going to have to take the square root of this, because this in fact is D squared. So once you take the square root, you do get 3.23. Okay, to find, there we go. I was going to say something. All right, to find your other missing angles now, we are going to have to use our properties of parallelogram. We know that all the angles of a parallelogram add up to 360 degrees. And the opposite angles are congruent. So theta, I have 30 degrees there. The opposite angle over here is also 30 degrees. And that leaves me with 2 times the angle that's remaining. So subtracting those, I get 300 divided by 2 is 150 for each of those angles. Okay. Once I know that, I can then use the law of cosines again to find the other missing diagonal. Okay, so diagonal C. So knowing a parallelogram, this is also B up here, that length. So I can use the law of cosine for that pink triangle now as well to find that missing diagonal. Don't forget that when you're setting it up, you take the square root to find your actual answer there of about 9.67. Okay, here we have this vertical tower, and we know that the vertical tower is 100 feet tall, and it's on a hill, and we need to find these guy wires that are anchored to this tower. Okay, we know that there's 6 degrees right here with the angle with the horizon. So that all depends on, we're going to use that information to find this angle in here. All right, to go downhill, we're actually adding that 6 degrees to this angle because there's actually obtuse in here. So that's when we're getting 96 degrees. When we're going uphill, our angle is actually a little bit smaller than 90 degrees. So 90 minus 80, or 90 minus 6 is your 84. So that's how we get those two measurements respectively. Your sides are 75 and 100 still, and then we can find those missing guy wired lengths. So this is D, and this is U, according to my formulas down here. And when I plug all that information to solve, we get about 131 and 118. The last thing we're going to do is we're going to use Heron's area formula to find the area of a triangle. So if you're given the 3 side lengths, you can still find the area. You just need to know what S is. To find S, you add up the 3 sides and divide by 2. Okay? So in our example here, we would have 22 divided by 2 is 11 for S. Okay? It's coming down to our formula. It's S times S minus A times S minus B times S minus B. So using that information, and we're taking the square root of that, we get about 16.25 for our area.